Hello again, this is another video on chapter 5. Let us continue. I hope you're doing well. So last time I think we stopped here at this point. We're going to continue and talk about other trigonometric functions and right triangle. So let's talk about that. So we know other trigonometric functions obviously are the ones we didn't talk about that much: tangent, cotangent, cosecant, and secant. So we know if t is a real number and x, y is a point where the terminal side of an angle of t radians intercepts the unit circle. So this, since the radius here is 1, right, this angle in terms of radian is the same as this arc length from here all the way to here. So we know about sine and cosine. Of course, sine of t is going to be the same as y over 1, which is y, and the cosine of t is x, right? So tangent is y over x, secant is 1 over cosine, so it's 1 over x, and cosecant is 1 over sine, so it's 1 over y, and cotangent is 1 over tangent, or x over y. And of course, denominators cannot be 0. Okay, so here is the point on the unit circle. X is negative square root of 3 over 2 and y is 1/2. So we can find sine, cosine, tangent, secant, cosecant, and cotangent easily, right? In fact, the x coordinate is cosine, the y coordinate is sine, and then we can find the rest of them because they're all related to sine and cosine, right? So here you go. This is sine, which is the same as y, so it's 1/2. Cosine is negative square root of 3 over 2. Tangent is y over x, and if you divide, right, do a little bit of, calculations on fractions, and we end up with square root of 3 over 3. Secant is 1 over x. 1 over a fraction is the reciprocal of the fraction. And if you take the reciprocal and rationalize it, we get that. Cosecant is 1 over y, and 1 over 1/2 is 2. Cotangent is x over y, so we just do the calculations and we get negative square root of 3. Now, at this time, you should be able to create this table from memory. Okay, so these are very famous angles: 0, 30, 45, 60, 90. And then first you find sine and cosine easily. You remember, you really have to memorize only these three, but later we're going to learn something about cofunction identity, and we know that if two angles add up to 90, then the function of one equals to cofunction of the other, like sine of one equals to cosine of the other. If two angles add up to 90, we're going to talk about that in a second, then the sine of this is the same as cosine of that. Tangent of that equals to cotangent of that, and so forth. But we talk about that in a moment. But for now, you should be able to create the sine and cosine, and the rest of this table can be found by dividing, right? So tangent is sine over cosine, so 0 divided by 1 is 0. 1/2 divided by square root of 3 over 2 is this. This divided by this is 1. This one divided by that one is the square root of 3. Now 1 divided by 0 is undefined. So that means tangent is undefined when the angle is pi over 2, right? Because you can't divide by 0. Now secant is 1 over cosine, so just take the take the reciprocal of these numbers. Reciprocal of 1 is 1. Reciprocal of this is 2 over square root of 3, and rationalize it, you get this. This divide, take the reciprocal of square root of 2 over 2 is 2 over square root of 2. Rationalize it, you get square root of 2. Reciprocal of 1/2 is 2. Reciprocal of 0, think of 0 as 0 over 1. So reciprocal of it would be 1 over 0, and 1 over 0 is undefined. So cosecant is 1 over sine, so 1 over 0 is undefined. 1 over 1/2 is 2, 1 over 2, that is square root of 2, and so forth. So cotangent is cosine over sine. So cosine over sine is not defined as 0. And the rest of it you can find by dividing, right? So this should be able, you should be able to create this from memory. You should actually sit down and create this chart from memory. That's something you should know as a trig student. All right, suppose alpha is an acute angle. Acute means between 0 and 90. So that means alpha is in the first quadrant. With cosine alpha is 5 over 13. Find sine and use this to plot alpha in a standard position. And then number 2 is find sine and cosine of the following angles that are related to alpha. Okay, first of all, to find alpha, we know alpha is in the first quadrant. And remember the definition of cosine is x over r. So if cosine is 5 over 13, you can think of x as 5 and r as 13, right? So here you go. So x is, so here x is 5. So you can think of a triangle, I mean not triangle, but a setup like this when x is 5 and this is what, 13. That's one way to think about this. Another way to think about it is think about unit circle like I did here, right? In the unit circle, cosine is x. That means this whole thing is x. And r is always 1, of course, right? In the unit circle. So we're going to say the x coordinate of this point is 5 over 13. That's cosine. And so if the cosine is 5 over, if x is 5 over 13, right, we can find sine by using this identity again, right? Remember the identity? Cosine squared plus sine squared has to equal to 1. So we raise the cosine to second power, we get 25 over 169. And then isolate sine, we get plus and minus 12 over 13, right? Because 1 minus 25 over 169 is going to be 144 over 169. And when we take the square root of both sides, right, we're going to end up with, not here, but here, right? Sine squared equals to that, and take square root of both sides, we get that, right? All right, now, is it plus or is it minus? Well, it's plus because it's in the first quadrant. We are told that right here, right? So we take the plus, not the negative. And so that's the sign, and we did the number 1, right? Now, number 2, A part says, if you know cosine of alpha equals to that, right, find cosine of this. Well, that's pi plus alpha. So if you think of this as alpha, right here, if this is alpha, right, if you add pi to it, so if this is alpha up to here, pi is 180. If you add 180 to it, we get here, right? And obviously, you can think of it also as, instead of alpha plus pi, you can think of it as pi plus alpha. So if you think of it that way, we say, okay, here's pi, and then here is alpha. Well, obviously, here alpha is the reference angle, right? And as you see in this setup, you see when you reflect it over the origin over here, right? Then you can easily see that the cosine of this is negative cosine, right? Cosine of the angle over here, which is pi plus alpha, is actually negative cosine of alpha, which is from here to here. That's cosine of alpha, and this is cosine of pi plus alpha. So cosine of pi plus alpha is negative cosine alpha. We know cosine alpha, we are given that, so it's negative 5 over 13. Now what is sine of this? Well, again, sine is related to sine, and in the previously we find the sine to be 12 over 13, remember? So sine here, if you think about it, sine of alpha is this much, is about right here, this much, right? And that is sine of pi plus alpha is that much. So it looks like sine of pi plus alpha is negative sine alpha. So it's negative 12 over 13. Okay, so let's do the B part. 2 pi minus alpha. So if you come all the way 2 pi and then subtract alpha, obviously alpha is what? Reference angle, which is the same as that. So that makes the cosines the same and the sines have different signs, right? So you can easily see that cosine of 2 pi minus alpha is the same as cosine alpha is right here, right? You see it right there. Right there, that's cosine. And then sine of 2 pi minus alpha, sine of 2 pi minus alpha is this much from here to there, right? And that is negative sine of alpha, which is that much, right? So this is negative of that, obviously. Now the C part, 3 pi minus alpha. So 3 pi, that's 1 pi, 2 pi, 3 pi, and then minus alpha. Again, obviously, this angle right here is a reference angle, which is the same as this angle here. So that means the cosines are opposites, but the sines are the same, right? So the sines are the same as you see right there. Okay, I'm making a mess here. So cosines are opposites, and the sines are the same. Again, we are given cosine, and the sine we found in step 1, right? That was the sine, and that was the cosine, remember? Okay, the last one seems to be tricky, but is not. When we learn about cofunction, it's very easy to see it. But for now, we are going to think of it as pi over 2 plus alpha. So pi over 2 is this much, that's pi over 2, and then plus alpha, right? So alpha is this angle. It's not the reference angle, it's this angle, right? So now if you notice here, this alpha here, this angle right here is the same as this angle right here, right? Now, obviously, as you see, cosine of this angle seems to be, let me draw it for you. So cosine of this angle seems to be the same as sine of this angle, right? They're both, positive, and in terms of value, they're exactly the same. And then, cosine of this angle equals to sine of this angle, right? And sine of this angle, which is this distance here, seems to be the same in terms of values the same as this much, but opposite, but negative. So is in sine of this angle is negative cosine of this angle, right? Now, from the picture is obvious what the answer is, but in terms of analyzing it, we're going to analyze this something similar to that later when we learn about complementary angles. Angles that add up to 90 degrees. But for now, you see from picture why this is true, right? Cosine of pi plus alpha, this cosine right here, right? That is negative of this. And sine of this, which is this little part here, let me erase that, and the sine, which is this part, is exactly the same as cosine of this angle. All right, so now even an odd function, in algebra you learn that f of negative x equals to f of x, then f of x is even. Like, for example, x squared function is even because x and negative x have the same function value as you see up there, right? And x to the third power, which looks like this, f of x, if this is x, f of x and f of negative x, this is negative x, are opposites. And you learn that in algebra. Now, we can apply this in trigonometry to sine and cosine and the rest of them. So as you see here, if this is x, if this is t, angle t, then this is angle negative t, right? So as you see here, cosine of negative t is the same as cosine of t. That means this expression is true, so we can conclude that cosine is an even function, right? If you make a cosine as a function like f of t, remember we can consider the input of cosine to be a real number, so we can make a function out of it. So f of t is cosine t, and as you see, f of negative t is the same as cosine, is the same as f of t. And cosine is an even function. Now for sine, on the other hand, if you think of sine, you see sine of t is this distance here, but the sine of negative t is this distance. So that means sine of negative t is negative sine of t. So that means sine is an odd function, right? So sine is an odd function. So sine of negative t is actually negative sine t, right? And cosine of negative t is the same as cosine of t. And that becomes useful later on. Now, what about tangent and secant and cosecant and cotangent? Well, all of them are related to sine and cosine. So based on that, you can figure out whether tangent is odd or even. Looks like tangent is odd. Secant is even because secant is related to cosine, 1 over cosine. And cosine is even, so secant is even. And cotangent is odd, obviously, because cotangent is cosine over sine, and the sine changes sign. Sine of negative t is negative sine t. So cotangent is odd. Cosecant is related to sine, so it's odd. So it looks like they're all odd except for cosine and secant. Those two are not odd, they're even. So cosine and its reciprocal are even, and the rest of them are odd. So if sine is the square root of 2 over 2, what is sine of negative t? Well, we know sine of negative t is negative sine t, so it's negative square root of 2 over 2. If secant is 3.1, what is the secant of negative t? Well, secant of negative t, since secant is an even function, is the same as secant t, so it's the same. It's 3.1, right? If you forget about secant, tangent, cotangent, and cosecant, just think of sine and cosine, right? And you can easily see whether they're odd or even. Okay? Now suppose we have a point on the circle that is not a unit circle. So let's say we have a point here, right? And the radius is not 1, but is r, right? And we have an angle here, theta. Or t, you can call it t or theta, doesn't matter. Okay, so what we see here is that by definition, we know sine is y over r, and cosine is x over r. And if you put a 1 under here and cross multiply, you get two expressions for y and x. So x is r cosine theta, and y is r sine theta. So if you're in the coordinate plane and you just have a point here, if you know the distance from here to here, whatever that is, you can write the coordinates of this point as r cosine theta and r sine theta, right? And this becomes really useful in physics, for example. If you know, if you want to analyze the movement of an object on a circle, you see this pretty useful because this would be how x coordinate is changing, and this would be how y coordinate is changing, right? It's very useful. So example, it says evaluate cotangent of 11 pi over 4. Now we know cotangent, of course, is cosine over sine. So 11 pi over 4 again, if you use reference angle, and we did few of these already, but this is 11 times 45, right? So is 11 pi over 4. You end up with what? You are going to end up with, let me see if we draw it correctly here. So 11 pi over 4 might be a typo here because that's 1, 2, 3, 4. That's 5 pi over 4. So let's make this 5 pi over 4 instead of 11 pi over 4. It's not 11 pi over 4. 11 pi over 4, it's going around, it's like more than 2 pi, okay? So let's make this 5 pi over 4. So the cotangent of 5 pi over 4, which is the angle over here, right? That's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. Cotangent of 5 pi over 4 is negative cotangent of pi over 4. How do we know that? Well, let's see. We could do this first and then do this. I'm going to switch this later in the notes, but for now, so this is going to be negative, so let me write it here. So cotangent of 5 pi over 4 is going to be, now the cosines, this is the reference angle, pi over 4, right? 5 pi over 4, this is reference angle. So the cosines are opposites. So this is going to be a cosine of 5 pi over 4, because that's cotangent, over sine pi over 5 pi over 4, right? Now we know cosine of 5 pi over 4 is negative cosine pi over 4. And the sines are also negative, so it's negative sine. I mean, they're opposites, right? Sine of this and sine of this are opposites, and cosines are opposites. So negative over negative is positive, right? So what we end up with is that is that this angle has to be cosine pi over 4. Negative divided by negative is positive, so this is just the square root of 2 over 2 over square root of 2 over 2. So it's a positive, not negative. Okay, remember there was a typo there? So here you go. So, so that means the cotangent of 5 pi over 4 is actually equals to cotangent of pi over 4, the same, right? In this case, because this is 5 pi over 4 and pi over 4 is the reference angle, right? So cotangent of 5 pi over 4 is the same as cotangent of pi over 4. Now we don't know that right away, so we have to convert it to this form to figure it out. Okay, so I'm going to modify this and write it this way. So the answer is 1. Okay. All right. Evaluate tangent of 330 degrees. So hopefully this is correct. Yes, this is drawn correctly. So 330 is basically right there. That's 330. Now tangent is what? Is sine over cosine. And sine of 330 obviously is what? And 330, the reference angle is 30. So sine of 330 is negative sine 30, and the cosines are actually the same. Now, what is sine 30? Well, is 1/2, so that would be negative 1/2. What's cosine 30? Square root of 3 over 2. So it's 1/2 divided by square root of 3 over 2, right? So that would be negative 1/2. It would be a negative, is 1/2 times negative 1/2 times 2 over square root of 3, and the 2's go away. So that would be negative 1 over square root of 3. That's what I have here, right? That's a negative. And then you rationalize it, you get negative square root of 3 over 3, okay? And that is the same as negative tangent 30. Okay, so so that's another example. All right, if sine of t is 3/4 and t is in quadrant 2, find cosine, cosecant, tangent, and cotangent. Again, we can think of this as in unit circle, right? We can think of it as being in the unit circle, and the y-coordinate is 3/4, right? So this is 1, and the y-coordinate of this point is 3/4. You can think of it this way, or you can think of it this way, in terms of what? In terms of r, right, being 4. So if r is 4, then y has to be what? Has to be 3, right? That's how sine ended up being 3 over 4. So you can either think of it this way or this way. Gradually we're going to see that this is more powerful because we can use identities, but there are many application problems we can do it this way. In this case, we're going to do it this way. So this is 3, this is 4, and we can use Pythagorean property to find the x here, right? So if this is 4, this is 3, this is 4, then 4 squared equals to 3 squared plus x squared. So we can find x squared equals to 16 minus 9, which is 7. So x is plus and minus the square root of 7. We don't want the positive because here this is negative. So that's negative square root of 7. All right, now that we have x, we have y, and we have r. Well, what else do we know? Do we need to find that? That's all we need. Okay, so so let's you can do that easily. So what is cosecant is 1 over sine, and what is sine is 3/4, right? So it's 4/3. Now, we also, without this setup, if we could use identities, we could just find what? Find cosine if we have sine, right? So we had that option too. And I gave you that option. If you think of this as just the y-coordinate, you can use identities and you're done. You can find sine and cosine, and once you have sine and cosine, you have everything, right? Or we can think of it this way and find x, y, and r. Once you have x, y, and r, you have all 6, because they're all related to x, y, r, right? All right, so you see you have many options, many different ways to do these problems. So if you have sine and cosine, then you have the rest of them. And I'll let you look at this. You can stop the video and look at it. Now remember, you're in second quadrant, so whenever you get plus and minus, you have to decide which one you want. So in this quadrant, cosine is negative and sine is positive. So that makes tangent negative. It makes cotangent negative, because one cosine and sine, one of them is negative. It makes tangent and cotangent negative. It makes cosecant positive because it's 1/sine. And it makes secant negative because it's 1/cosine, right? And you see them right here. And I'll let you look at this and figure it out if you want to stop the video. All right. If cosine is negative 1/3 and t is in third quadrant, find the rest of them. Again, we can use identity. Identity, cosine squared plus sine squared equals to 1. And we have cosine. We substitute values for cosine right here. You see negative 1/3. And we end up with sine. If you take that's the square root of 8 over the square root of 9. There's a negative here. So square root of 8 is 2 square root of 2, and then over 3. This is square root of 9, right? So this is sine. Now, is it negative or positive? Well, right away we pick the negative because we know here sine is negative. Okay, what is cosecant? It's 1/sine. Just take reciprocal of this. And what is secant? Is 1/cosine. Take reciprocal of this. What's tangent? Sine over cosine. You just divide them. It's just arithmetic with, fraction a little bit, but nothing difficult at all. Okay? All right, so let's look at some identities. Here are some very basic identities in trigonometry. We already know tangent is sine over cosine. We know cotangent is cosine over sine. And we know all the reciprocal identities, right? Cosecant is 1/sine, so sine is 1/cosecant, right? Secant is 1/cosine, so cosine is 1/secant, and so forth. So you want to write these down a few times so you get used to this setup. Remember, we talked about that there is only one cosecant is 1/sine, not 1/cosine, right? There would be two cos then, right? All right, so here find the indicated value if it exists. So we got secant 60, cosecant 7 pi over 4, and cotangent 3. Okay, secant 60 is 1/cosine 60, right? And cosine 60 is 1/2. So it's 1/1/2 is 2. Now, remember I told you have to memorize 30, 45, and 60 degrees, cosine and sine? Well, using those, you can find tangent, cotangent, secant, and cosecant of these numbers too, if you know sine and cosine. If you don't know an angle, of course, you use a calculator. Now, on the calculator, let me show you, on most calculators, we have 3 functions. We have sine, right? You see right here, sine. We have cosine, and we have tangent, right in the middle of the calculator. Now, We do not have cosecant. Well, because we know cosecant is what? Is 1 over sine. We do not have secant on the calculator because we know secant is 1 over cosine. And we do not have cotangent because cotangent is 1 over tangent, right? So if you want to work in degrees, make sure you change the mode to degree, right? And you do it. So some of these you can do by in your head because you know 60 and 30 and all that, and you know reference angle, right? But some of them you have to use calculator because you don't know what they are. Like tangent 3, what's tangent 3? We don't know. So for that, we make sure we are in degree mode and we put 1 divided by tangent 3. There. So that's the, well, tangent 3. Let me see. Oh, this is in radian. So now this 3, since doesn't have degree, has to be in radian. My mistake. Let me change to the first one, 60 degrees. That's degree. But the second one and the third one are radian. So I got to change to radian. And you see the answer changes dramatically, right? It's a -7 and 19. Very different answer. Okay, so -7.015 for this one. Okay. Now, I know you can use calculator with 60 degrees too, but you shouldn't. You should practice with those that you memorize, 30, 40, 60, 45, and 60. All right. Now, the Pythagorean property that we've been talking about and using for a while can be converted to 2 more, this one and this one. How? All you have to do is divide everything by cosine squared, and you get a new identity, which is another form of Pythagorean identity. It's called still Pythagorean identity. 1 plus tangent squared is secant squared. And if you divide everything by sine squared, then you get 1 plus cotangent squared equals to 1 over sine is cosecant squared. So 1 plus cotangent squared is cosecant squared. So we got 3 forms of Pythagorean identity. This one, that one, and this one. 3 forms. 3 forms of Pythagorean identity. If cosine is 12 over 3 and t is in quadrant 4, find the value of sine. As we talked about this, now I know we do all these with machines nowadays, but it is very important for you to understand how you can do this by hand. So method number 1 is to think of the definition number 2. Remember we said think of r, x, and y, right? So you can think of this as, because it's cosine, so this is x and this is r. That's one way to look at it. Another way to look at it, you can look at this as just this whole thing is the x coordinate of a point on the unit circle, right? Is the x coordinate of a point on the unit circle, and it can't be here, can't be in the first quadrant because you're told is in the fourth. So it has to be here somehow, right? Somewhere. Oops, I erased it right here. And then the x coordinate of it is what? Is 12 over 13, and we assume that the radius is 1. So we are on unit circle. That's another way to look at this, right? And then you can think of the identities. You can use identity and look at it that way, right? So either x, y, and r, or you can think of it as r equal to 1, which is the unit circle, right? Like I did here. Or you could just use identities, right? Just use identities. 3 different ways to do it. So here we go. The first method, assume this is 12, this is 13. So you see this is the unit circle, but this is the big circle that this point is on, right? It's not a unit circle. So this is y, this is r, and this is x, and this is the origin right here, right? And the angle, whatever the angle is, doesn't have to be this one. It just ends up being here. I'm just showing you one example of it, right? So the angle is here, terminal side of it. So we are given that the cosine of it is 12 over 13. So that is a key, that this is 12 and this is 13. And we can use Pythagorean identity because we know r and x and y are related this way. And we see that y is plus and minus 5, and we're going to pick the minus 1 because we know we are in fourth quadrant, right? And we can find sine by using y over r. So sine would be negative 5 over 13. That's one method. Another method is to think of, we can think of, again, x to be 12 over 13, right? Which is right about here. And then r is 1, which is unit circle, so that's 1, right? Now, y would be that much, right here. How much? Well, we can use r here is 1 now, so we can use just the identity. Sine squared plus cosine squared equals to 1, right? Which, of course, that's the same as using the unit circle, but I want to make sure you understand that the difference between this big circle and that unit circle and how to deal with them. That's why. Okay, so in this case, y ends up being plus and minus 5 over 13, and we pick the negative because we know it's negative here. So y is this little part here, which is negative 5 over 13. And then we can find cosine, of course, easily, and sine. If you have cosine, we can find sine, and so forth. All right, so, and of course, the third method is forget about drawing anything, just use identities, right? Sine squared plus cosine squared is 1, so sine squared equals to that, and sine is plus and minus that. How do we know which one to pick? Well, that tells us. You have to pick the negative, because we know in the fourth quadrant, sine is what? Negative. So we pick the negative, and we are done. So the third method is more powerful, and that's why we are learning what? Identities. So periodic functions are functions that they repeat themselves, basically. So a function is said to be periodic if there is a real number c, so that f of t plus c is the same as f of t. That means after c units in the input, the output is the same. See, they're equal. So cosine, and in fact, all 6 trigonometric functions are periodic. And in the next chapter, we're going to talk about graphing them and a whole lot more. But for now, we know all 6 trigonometric functions are periodic functions. An example is cosine, right? See, cosine repeats itself after each what? After 2 pi, after one complete term. So if you're here, cosine is 1. Then cosine is 0. Then cosine is negative 1. Then cosine is 0 again. Then cosine is back to 1. See? So it's periodic after 2 pi, right? So at 0 is 1. Then when is it that is 1 again? 2 pi later, right? And this is true for any angle. Let's say, for example, we are at 90, like pi over 2. When is it that the cosine again becomes 0? Well, 2 pi later, right? Coming to this 2 pi later. If you add 2 pi, you go back to 0. All right. And the period for cosine ends up being 2 pi. In fact, the period for cosine and sine and secant and cosecant are all 2 pi. And the period for tangent and cotangent is pi. We'll study this in chapter 6, as I said. All right. Now, we can apply what we learned in 5.4 to right triangles. This is really easy, so I'm going to do it in this video too, because it's really not that hard. So we're going to use the first definition, using right triangle, to write ratios. And this helps us, for example, if we know this side and I know this side, then I can find tangent of this angle, right? If I know this side and I know tangent of this angle, then I can find this side, right? So you see, in these setups, there are 3 unknowns, right? See, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, right? So if I know 2 of these, I can find the other one. And that's how we're going to use these in this section, right? So it says, using the triangles shown, evaluate sine, cosine, tangent, secant, cosecant, cotangent. Okay, well, here's the angle. And we know again, the right triangle, even though the orientation has changed, but that's not going to confuse us, because we know the definition of sine is opposite over hypotenuse. So it's 4 over 5. And the same is for the other 5. So I want you to stop the video and make sure you understand why these are equal to what they are. And I'm going to move on. So here is another example. Now, here is where I was talking about that if 2 angles add up to 90 degrees, like inside a right triangle, obviously these 2 angles add up to 90. Why? Well, because this is 90, so they have to add up to 90 for the angles to add up to 180, right? So these 2 add up to 90, and notice that the cosine of this angle, which is A over C, is the same as the sine of this angle, because sine of this angle is opposite over hypotenuse, right? So, and also, have them over here, but any function of one angle, maybe theta, is the same as cofunction of the other one. Cofunction of, can write here, alpha. Now, what do I mean by function, cofunction? Sine, cosine, tangent, cotangent, secant, cosecant. And these are called cofunction identities. If 2 angles add up to 90, then sine of one is the cosine of the other, and the other way around. Cotangent of one is the same as tangent of the other one, and so forth. So these are true for 2 angles that add up to 90. Okay? All right. Now, that gives us cofunction identities. So cotangent of t is the same as, cosine of t is the same as sine of pi over 2 minus t. Why? Because pi over 2 minus t plus t is pi over 2, because the t's get cancelled. And we just said, if 2 angles, think of this as alpha and think of this as beta, this whole thing. If 2 angles add up to 90, then function of one equals to cofunction of the other. And that is true for all of these. See, cotangent of this is the same as tangent of t, because t plus this is pi over 2. Okay, and so forth. So if you're given sine of t is 5 over 12, and somebody says, okay, what is cosine of pi over 2 minus t? Well, right away you know this plus that is 90. So cosine of this has to be the same as sine of this angle, right? So that means the cosine equals to 5 over 12 as well, right? And find the measure of the missing angle and the length of the missing sides. You see, that's where we set up a ratio that has the given numbers and the unknown. So we are given 7, we are given 30, and we are given 2 unknowns. Now, to find the measure of this is easy. You just have to subtract from 180 and you get it. So that's 60, right? This is done. Now we have to write the ratios so we can find what? So we can find the A and C. Now to find A, to find C, we can write sine of 30 degrees is 7 over C, right? Like this. And as I said, there are 3 unknowns, right? But 2 of them are known. This one and this one. Sine of 30 is 1/2, and we solve for C. So C is 7 divided by 1/2, which is 14. So C is 14. Now we can use Pythagorean or we can use trigonometry to find A. If you write cosine of 30 equals to A over 14, right? A over C. So A is going to be C times cosine 30. C is 14, so use a calculator. It's about 12.12. Okay? Now, there are 2 important concepts in application problems, and those are angle of elevation and angle of depression. So if you're standing here and there is a tower in front of you, let's say this is a tower, so you look up to the tip of the tower, right? This angle, that line from your eyes to the tip of that tower makes with the horizon is called the angle of elevation. The angle of elevation. Now suppose you're standing here and you see an ant here. You're looking at it. Then the angle that line from your eyes to the ant makes with the horizon is called the angle of depression. And those are pretty useful in trigonometry, those ideas. So let's look at an example. So suppose you have a tree that you know the tree is 370 foot tall, right? It's a giant redwood tree that you can find them around San Francisco in California. So if you walk a certain distance from the tree and measure the angle, let's say you know this tree is 370 foot tall, so you walk this way and you stand over here and you measure the angle of elevation to the tip of the tree, and the angle of elevation turns out to be 60 degrees. Now, how far are you from the tree? See, magic. You can find how far you are from the tree without anything to measure with. You have to have something to calculate with. So x equals to here, tangent of 60 is this opposite divided by what? Adjacent. And in this setup, there is only one unknown, and we can cross multiply to find it. So x is 370 divided by tangent 60. You can use a calculator to do that. So 213.62 is the answer. All right, so this is the end of this video. It's a little longer than normal, but that's okay. And least we finished something, right? We finished chapter 6, so I see you in chapter 5. We'll see you in chapter 6, okay? Take care of yourself and others, and I see you in the next video.